with IHP. Yeah, so actually looking back, last year actually in summer, this was when we launched IHP. This was I think a launch some photos and screenshots from launch day. It's actually summer in Germany. You can see on the screenshot, and yeah. So the interesting thing is actually the IHP ecosystem is it's not even a year old actually. So it's only in summer IHP will turn 1 year old. So I think we actually achieved quite a lot already in this short amount of time. Yeah. And I think you can actually see this and when you look at the GitHub star history of IHP, you can actually see that this is a good indicator for like community growth, I think. And yeah, we are continuously growing. I think I think if we just continue this, we will soon be probably like one of the largest frameworks. Like the largest framework in Haskell actually. If you look at the GitHub repos, that's actually we are already place 31 of the top Haskell repos on GitHub, which is pretty amazing. Yeah, but way more to go. And some community numbers also interesting to take a look at actually. So we are, I mean, even our Slack community is now like growing larger and larger, or like GitHub's still growing, even if it's not like, even if we try to move to Slack, and this is very very great, I think. Yeah, and yeah, it will probably continue in the future. Yeah, another trend I think we should have in mind is actually when you look at like this kind of space, we have like a trend moving from untyped to type-safe languages and object-oriented to functional programming languages actually. If you look at like recent releases of software technologies, you can actually see that there's an ongoing trend across the software world to go for more type-safe technologies. Like Arabi 3 has like a basic type system now. PHP 8 has proved support for types. TypeScript is rising. Python also added like some basic type stuff in 3.6. And same as with functional programming technologies. We see that with React, which has added functional components and made this like the primary way how it works and replacing class components. We see that with Java 16, which was recently released, which now also has immutable records. Java 8 with closures. JavaScript has actually a stage 1 proposal for adding pipeline operators. We have like Redux. We have like the whole flux pattern in the JavaScript world. So you can see there's like this trend of more functional programming techniques moving into mainstream languages, and at the same time we see a bigger adoption of type-safe technologies. And I mean, if you look at the trend line, you can clearly see it's going to be more functional and more type-safe, and this will probably lead to more people trying out Haskell in the future. So given enough time, a lot more people will probably try that out. It will take, and so the IHP community will probably grow a lot. And yeah, and even right now, even after not a year after release, we already have a couple very cool IHP apps running in production. There's a lot more. So just like some screenshots, and I mean we are just getting started right now. So I think I think we can clearly say that like nobody can say no one is using Haskell anymore. I think I mean there's now lots of Haskell apps in production, and there will be a lot more in the future. So yeah, so that's to the state of IHP. Let's quickly talk over what's next. So I thought like I actually just want to share like 2 ideas I think which could be super interesting for IHP, which might not be released in the next version, but some things we have been working on, and some of them we also shared at some point, I think. But some of them are, like, I think, very interesting. So the first thing is actually server-side components. I think this is an interesting space to explore for us. We are like at a very good position actually to explore that, I think. With Haskell, we have very scalable, easy WebSocket support and stuff like that. And I think this is specifically very useful when you work with interactive, for example, with interactive data tables, where you can apply custom filters, conditions, limit order bys, and stuff like that. You can actually create like something like React, but running on a server, which means you can basically avoid lots of like data synchronization issues you would otherwise have. It's probably a good, like auto refresh, it's a good step probably to use, or a good tool to use in certain examples. I will shortly say a screenshot of how I think this, like how this could be used in practice. But in general, you can see from this code example, you can actually see it's basically the same as with a React component. You have like a counter data model. You have a counter controller, which is just kind of like collection of actions. And then you have a component with some initial state, which for our counter example is just 0. And then you kind of have a render function, like in React basically, which just renders our Xcode. And and inside there we have, in the on-click handler, we actually have this magic dispatch action, which will actually, when that is triggered, this will basically send an event back to the server and run the increment counter action. This will like update the state, and then the render will be called again, and then this would move back to the client again, and it will be kind of re-rendered, but only that component. So this means you can kind of build like small single-page app components kind of inside your like normal app, but without any kind of JavaScript mostly. So this is, for example, great when you have something like this, like some kind of a table where you are looking up lots of data. You have lots of filter possibilities and stuff like that. You could write lots of JavaScript to make that work, or you could use maybe a server-side component, because then it's probably a lot easier actually. And I mean, this is just a specific example, but I think in the future we could have maybe an ecosystem where there's lots of actually components you could mount into your application and use, instead of just kind of writing your own components. You could probably use like some data table component maybe inside your IHP app, and this would just work with your kind of data records maybe out of the box. So there's lots of possibilities here on that space. I think this will be really cool for IHP. And so with the recent WebSocket update, we actually we've been improving the APIs for making that possible. And I think now we could actually build on top of that this idea. I mean, we find these ideas a lot, but like I think we had the idea a long time ago already. So but now we can actually find it implemented. So yeah, that's to that. And another thing I think we haven't shared that at all actually, which is improved data mapping actually. This is something we've seen in a lot of IHP apps ourselves. Basically, there is the problem. Sometimes you have like some table, like in this example, we have properties like buildings, and like a property can, like in our application. So this is actually from some real world application. So we just reduce the table to be a bit more like good example, but it's actually way more like has way more fields and stuff like that. And actually, a property in that case can be like a sell property or a rent property for the basically property marketplace. And when it's a sell property, it has a price buy basically set, and when it's a rented property, it has a price rent basically, and but otherwise the field is empty. And yeah, so like we basically have two kind of properties inside our database table, and I mean we even have the enum for kind of like deciding that. And this actually happens across a lot of apps we've seen, that we are storing different kind of things with usually even with enum to actually decide what this is, and they have kind of different like rules for that. For example, here we have like if the marketing type is sell, then the price rent is null and price buy is not null. If marketing type is yeah, and so basically these are kind of the rules. And how IHP maps this right now, it's this, right? I mean, we have like a simple property data type with a price rent and a price buy, and both are maybe ints, which makes sense because it could be null if it's like a rent property, then it's not null. If it's a sell property, then the price buy is not null, and yeah. But the problem is actually when you use that in practice, you always have to use from just basically. So this means when let's say someone enters some property which is manually inside the database, which is for rent, but it doesn't have a price, so it's null. I mean, this actually has happened in different contexts for us. And this usually crashes the whole application, but inside the render function. And this is kind of a problem. And this, I mean, especially inside these cases where you have enums to actually map to different kind of types, you always have this, that you have to manually unwrap your data. You have like these kind of from just stuff happening. So this is kind of unsafe code, and this is not, I mean, not very nice. The more like the more this comes up, the more like visible this gets. The problem, it's kind of something which happens when the data model is getting more complicated. And so we've been thinking about how we could, for example, solve the problem, because this indicates we've done something wrong with how we are modeling the data. And then if you just look from kind of scratch, you can see a better data mapping for this data structure would actually be to have two separate data models for one database table. Right now, we only have like one-to-one mapping, basically one database table, one Haskell record, basically. And for our properties here, it would actually be nice to have one property cell, which has a price buy attribute, which cannot be null. And we have a property rent, which is a price rent attribute, which cannot be null. But there's no other attribute which could be null or something. So this actually removes this kind of error completely, because the data mapping doesn't allow this error that you try to access something which is not there. And when you use that to rewrite, for example, the render function we've seen, you can see there's no from just. So this will always, the render function will not crash because of this. And yeah, so we think clearly for some cases it makes sense to be able to have a kind of different mapping for SQL tables actually. I mean, they could work this, like even if you have different mappings, this would probably work the same from API standpoint. You could just query a property cell, and that would be equivalent to kind of querying the property, but with a certain filter applied. And I mean, creating a new record of that is also like kind of the same. It's just that you cannot set certain fields kind of set your new record basically. And and then we've been thinking about how we could, for example, allow this definition to actually work. So how you could, for example, like define kind of this data mapping from how your database table maps to your Haskell code. And so we've been actually thinking the best way is actually to use SQL for that. So I mean, this is a kind of advanced feature probably, but it makes sense to actually have this in SQL, because that way you even like avoid the error at the database level. So at the database, it's no one is actually able to insert invalid data. So we've been thinking that we actually use SQL constraints, like check constraints, to actually, for example, like tell IHP, basically the idea is that we put this check constraint into the schema SQL, and then IHP is smart enough basically to detect, okay, there's a check constraint for this model. There are kind of two ways how I can display it, and then basically make kind of also additional to the base data record, generate more data records for like these special cases kind of. But it could then automatically detect, okay, this like when the marketing type is cell for the specific case, it cannot be null, so so I don't need to wrap it in a maybe and stuff like that. So basically, what we are targeting is basically we want to be able to, from one database table, we want to be able to have multiple database records in case this is needed for the application, to avoid the issue we are facing in reality when our current data mapping is kind of too rudimentary. And yeah, so I mean, our example was actually pretty simple, but if you know the real database table, how it looks, you would suddenly see actually how it makes sense a bit more, even because it's actually usually this happens when it's quite complex database table, and then it actually helps to really clean up actually the kind of like the Haskell code and stuff like that. So this is definitely something we think can provide lots of value, and we've seen that happening in production. And yeah, I would actually, if someone is actually has seen like this a similar problem, actually, maybe we should actually talk at some point about that, because I think this feature could really reduce the problems at like in that problem space, basically. Yeah. So that's actually next big features we have. In like two of the next big features we have in mind. There's a lot more. I think it's just something like two features I think were worth talking about. The other ones are also very important usually, but yeah, only had short time slots. So one more thing is actually the IHP Partner Program. We already talked about that, I think, a while. For now, we can actually announce that we actually have two partners already in the new partner program. So the partner program is basically for IHP development and consulting companies, basically, because I mean we've been thinking. So we actually it would actually be amazing if everyone here probably could do IHP on his day job, right? And so therefore we are like we are actually focusing on building up the professional IHP ecosystem. Then maybe everyone at the future can actually work a lot more with IHP on his day job. That would be amazing. So that's why we are actually doing this. And yeah, so we are actually very happy that Sister West, which is a company by Finn Espen Gunnarsson, you know him well, I think, from his contributions to IHP. He's from Norway. And Comland, which is by Henry Lambert, he's also an active IHP contributor from Ireland. They are the first two certified IHP implementation partners. And yeah, so if you are interested actually in doing IHP at work, yeah, look out for these two companies. They are doing IHP in production. They are doing great work. And if you are interested in that, definitely check both of them out now. Yeah. But there will be more on the IHP partner program in the future. So it's just getting started. It's just something I think to be out, so that the professional IHP system is also like going to start now. Yeah. Next is IHP version 1. This is also something we should probably quickly talk about. Will be released next quarter, hopefully. And yeah, so we still have a couple open bugs to fix. The APIs. Some APIs still actually need some improvement, so we still have some ideas we want to do before doing like the first release. Especially the bugs need to be fixed, because we shouldn't do a buggy version 1 release. So there's like still a bit to do. That's why we probably want to have a bit like slower release schedule for these kind of major releases to be able to fix all the stuff before it's kind of tagged into the release. So yeah, okay, that's kind of what's next for IHP. Yeah. So yeah, thanks everyone for actually building better software with IHP. Let's bring back some of the magic we set out to do, and I hope we can see each other at some point at the IHP conference, maybe in the future.
My name is Lars Lillo Ulvestad. I often respond to my middle name Lillo, but Lars is also just fine. Many people are calling me Lars. I work as a front-end developer in a consultancy firm called Cantega in Oslo, where I mostly work with TypeScript and React. And I really love front-end development, even though I honestly strongly dislike working with TypeScript and React. So I'm very much into functional programming and kind of on a journey of really utilizing those patterns as much as possible. So I made this application called Dill, actually started on a project in late 2019, I think. Dill is a barcode scanner where you basically, this is a mobile app where you can scan products with the barcodes and find out if they are vegan or not. That's a really simple concept, and it's also very heavy on crowdsourcing. So if you scan a product and it doesn't exist in the database, any user can just add a new product and upload an image and tell if they know it's vegan or not, or maybe you don't know. So that's also okay. And yeah, you can also browse and search products, and you can also propose changes to products in the database if something is wrong. We try to keep the quality high by engaging the community, so I don't have to do too much stuff. This is the web view, and it's pretty much the same functionality as the mobile app. In addition, I have some super user views that only I can use, and this makes it possible and easy to me to manage all the data in the same application. And these views are really easy to make with IHP. And I can also, for example, approve, reject, and even edit other product changes from other users. And yeah, it's all built in IHP, of course. And I figured I would not talk too much about the app itself, but on my journey towards deciding to go with IHP. I started this project by wanting to mostly do stuff on the front end and try to avoid using the back end at all, because I was a front end developer. And yeah, I'm a self-taught developer, and yeah, I like to explore stuff. And in this case, I wanted to make it simple to myself, just to not spread myself too thin. So I figured I wanted to make something like a simple stack. So I started with the 11T, and I created the 11T was for the web page, of course, and React Native for the mobile app. And Tailwind I could use for both of these applications. So that was really nice. And I also use some Elm. So now the complexity is already piling on just on the front end side. So I use some Elm for the search functionality, and also wrote admin views in Elm. And this got really tedious because I had to do it all all from scratch. And yeah, so I try to avoid writing backend code by using Hasura, which is a really good product, and it's written in Haskell actually. Yeah, it's a service that I have to log into and manage, and I have to deploy. Well, I chose to deploy it with Heroku, which is not a service to manage. And for file uploads, I needed to use something like Amazon S3. And but that wasn't. Let's see. Sorry. Yeah, so I needed to have some authenticated queries, and I had to use cloud functions in order to actually upload to Amazon S3. Let's see if I can just do this in full screen. That's a bit better. Let's see. Sorry about that. bit of technical. Let me try again. Well, no, it's all wrong. Let's see. Okay, yeah. So you can see the screen again. Yeah. Okay. Yeah. So I basically had to write Express.js. So I was at the point of yeah, needing to write backend code anyway, and in a language I didn't like. I don't know if you know this guy, Peter Levels. He's Levels.io on Twitter. He is kind of where I want to be. He's building apps by himself and trying to make some profits by it. And he has made famous stuff like Node lists and hood maps and Remote OK, which is a job board for remote workers. And he's making decent money on these apps. He built them completely by himself with no help. So you can ask yourself, what kind of genius technology is he using to be this productive? And the answer is not Angular and React and all these cool microservices, but it's PHP. As simple as that. He's not even using a framework, just writing simple PHP files. So I guess my presentation is getting a bit controversial now, because I will be talking warmly about PHP because it's so superior in how accessible it is. And it's really cheap to develop within that sense. You can get some shared hosting for $5 a month at GoDaddy or Namecheap, and yeah, you have your yeah, and you can deploy that after that. So how does it deploy it? Is it Kubernetes or Docker Swarm, or what does it use? He uses FTP, of course. So this is a stack that is really viable for him, and it makes loads of money every month. And I think that's amazing and impressive, and we should applaud that. So looking at this stack, it looks like a messy crapload of enterprise bullshit that eventually will crash and burn, because one of these dependency will probably be discontinued or some crap like that, and then I'm in trouble. So I realized I had to build a backend, and I wanted to do a simple stack in functional programming because I really liked Elm. And at this point, I was intensely searching for IHP before it was open source. No kidding. But I didn't find it at the time. So my dream was something like Laravel in Haskell. So Haskell is an amazing framework, but in a language that I don't want to work with. So the only thing I could find at the time was Yesod, which is awesome. Probably I haven't used it, but it's more modular than Laravel and Rails and much less opinionated. And this makes it much more demanding for a beginner because I have to make lots of choices that I'm not qualified to make. So this was too far off for me as a beginner for learning Haskell by building stuff. And in addition, it's very high on category theory in the documentation, like monad and applicative and these words. So you really need to get in depth in Haskell to get started. So this was just not possible for me at the time. So I went with Elixir and Phoenix, and this ticks off most of my boxes because it's pure functional. It's cool that it compiles to Erlang, and it's strongly typed, but it's dynamic, so it doesn't have those niceties that Haskell and Elm has. And it's very beginner friendly, so I just needed to read these two books. I read half of each, and I was pretty productive in Elixir, and that was cool. So I rebuilt 80% of Dill in Elixir and Phoenix. But deep down in my heart, I was an Elm developer wanting to have an equally good experience on the back end, and Elixir didn't quite do it for me in regards to that. If it compiles, it works, because I'm writing apps alone. I want to feel confident about what I write and avoid runtime exceptions as much as possible. And then at this point, we're pretty much there that I had rebuilt Dill in Elixir Phoenix, and I was ready to ship. And then I saw this advertisement on Reddit, Haskell on Rails. And it was just, this is exactly what I need. So this is so cool. So I just had to try it. And I went into the getting started guide. And it's just like you install Nix. That was pretty simple. And I installed the IHP new command line tool with a one-liner, another one-liner just to make a new IHP project. And then I just follow the tutorial and just build a blog. And it takes like 20 minutes and it's really easy. And then I actually built my first complete Haskell application. And it's a pretty advanced application with CRUD, and it's a fully functional blog. So that's amazing. That's just what I wanted to learn in a Haskell book. And now the tutorial also guides you to deploying to IHP Cloud. And that's just, that's really excellent. I've never seen any documentations or any frameworks giving you all this package just on the getting started guide. I often use hours of figuring how to deploy some new technology and hooking up the database and all that stuff. So there's almost no friction. One could really think that this is PHP. So yeah, I decided to do a full rewrite, take 2, because I wanted to learn Haskell so badly. And I really liked where the philosophy of IHP. So I decided to do 100 days of code challenge. This is usually done by complete beginners in programming, doing 100 days of code. I wanted to do it in Haskell. And this is a really good approach because persistence is king when trying to learn something like Haskell, and also consistency, that you maybe expose yourself to a little bit of Haskell every day can be very powerful. I also want to make a small warning here because 100 days is a lot. So I was pretty closing in on a burnout a couple of times because I was so happy about making stuff in Haskell and having so much fun, but having a full-time job, and if you have a family and a wife and kids and all that, yeah, you would, yeah, it would be too much. Wife or a spouse, I meant. So because of these tragic stories of all these developers wanting to learn Haskell, then getting stuck and giving up, I tried to think what did work when I did this. So my suggested roadmap for learning Haskell, based on my experiences, is a couple of bullet points. And the first one is have a project in mind. Think of something you really want to make, maybe something you can profit of, but an idea that really excites you. And even though it might be really complicated, don't worry about that. Just start doing small steps and just focus on building this idea with Haskell, if Haskell is what you want to learn. And start building as much of this project as you can in IHP without doing any books, really. Because then you will have some experience, and when you just when you generate a new IHP project, you have lots of references to Haskell, and you can change stuff and play with it and see how it works. Well, I hit the wall at some point and I didn't understand stuff, and then I started reading a bit of Haskell literature. So I read the Get Programming with Haskell. And one important rule with that is that just skip chapters that are irrelevant, because your goal is to build something and not to learn everything in Haskell. So I would say trust your own instinct. If you feel that the chapter is not relevant for you yet, don't feel bad, just skip it and read the stuff that applies to you. And that's another important rule. You don't need to learn all of Haskell to get productive. So I'm not very good at category theory. I don't really remember what applicative is, but I made one app in Haskell and it's fine. So that's no problem. So I would say when you have built some applications and got some practical references, then you can go and read another Haskell book, because then you have, then you know why you're reading this. Because lots of the Haskell books are kind of confusing and you have to learn lots of stuff. And maybe in chapter 11, you get to do a side effect. So I think that's not the optimal approach when you're doing web development. You want to just go right to the side effects, really. Yeah. Just revisiting this simple stack, wrapping up, I could remove Hasura and Heroku and use IHP and IHP Cloud, which is much nicer and much simpler. I didn't need Elm because the templating system of IHP is amazing, and why use Elm when you don't need it, even though I love Elm. So I could use, I could remove 11t, and Firebase went away. And I kept Amazon S3, but I had a couple of AWS services. So this is a truly simple stack that I'm really happy with. And this, I would say, is really comparable to the king of the web, PHP. It's very simple to develop in. And as soon as you get familiar with Haskell, this is by far much simpler to work with than PHP, JavaScript, Java, or whatever. This is true simplicity, and the type system helps you a lot. So I would say Mark and IHP contributors has not only succeeded in making Haskell more accessible, but it has actually made a really fierce competitor to PHP itself. So just ending this, I just wanted to show my proposal for the new PHP logo. So by that, I think that's it for me. Thank you very much.
Hello, everybody. My name is Zach Wood. In the IHP community, I'm best known as the developer of the Addix app, which, just real quick, Addix is a iOS app that lets you stream thousands of live concert recordings from the Internet Archive. So it's an iOS app, but it's written in IHP in the back end. I moved it over to IHP after having some less than stellar experiences in other languages, and I'm very happy here. But I'm actually not going to be talking much about Addix today. Today I'm going to be going into a little bit of a technical deep dive on the lifetime of an IHP request. So the idea of this talk is to answer this question. So when you send a request from, say, from the Addix app, you make some request to this URL endpoint. And this hits your IHP server, a bunch of stuff happens, and then you get some JSON going back to the app. So if you've gone through the tutorial on IHP, you know how to write, say, a controller action that renders JSON. But today I want to talk about how IHP works in terms of how it knows where to route that request and what's actually going on under the hood to hopefully give you a little bit better understanding of the true magic behind it. So at the very lowest level, just real quick, at the end of the day, we're working with sockets, which are just two computers talking to each other. And since it's two computers talking to each other, they're just sending a bunch of bytes back and forth. In the web space, we're working with HTTP, which is essentially just a contract that both computers agree on how they're going to talk to each other. So you see here, this is an example of a HTTP request that just sends some path to some headers and a request method, and that's HTTP. And like I said, at the end of the day, this is all just bytes. But as web programmers, we want to make interesting apps and don't really want to worry about the bytes. So first step was this thing called WAI, or WAI, which is essentially a Haskell library that understands the bytes involved with HTTP, makes it so you don't have to work with it directly. So this is just some sample code. Don't worry about understanding everything, just to show you how this works under the hood. Essentially, it provides a thin layer for making things nice and working with bytes. So as you can see here, we're responding with some status code, some headers, and then a body. So we don't have to write the HTTP response manually. Important for IHP is that WAI provides this application type. And again, don't worry about understanding the details here too much, but you'll see these types pop up later. So just wanted to make sure you know where they come from. And Warp is related to WAI in that it's the actual web server. So it listens on the socket, takes the incoming data, and then tries to return a response. I'm going to make a bit of a bold claim here and say that this IHP program, which is your main.haskell file in your IHP project, this is using Addix as an example. So at the end of the day, this code takes your entire IHP program, turns it into a WAI application, starts a Warp server, and runs that application. And you don't have to worry about any of that, which is the true magic behind IHP. So To prove this, we're actually going to dive in deep and see what's happening. So if we jump into the IHP Server module, we can see some simplified code here. It's a bit of a magic. We'll just go through really quick. This run function, which is what we're calling here, IHP server.run. Essentially, all it does is it sets up the database and then calls this run server function along with your configuration. And as you notice here, this is starting warp. So again, warp is that library that takes an application and starts up a server that listens for requests. So with run server, it starts up warp and uses this application function here, which is where the real magic happens. So run starts the server and application is run on every request. So as we go in deeper, we're going to want to look in application because that's where all the magic really happens. Notice here, there's this function front controller to Y app. Recognize Y, we talked about that earlier, just a thing that understands how HTTP works. So front controller to Y app is how IHP communicates with that further abstraction on HTTP, which then again will go down to the lower level and actually send bytes back and forth. We do this with this thing in IHP called front controller. A lot of types here. Again, this is just a high-level overview, so don't worry about understanding exactly what every type does. But essentially, the job of the front controller, which we saw here in our main file, is to tell IHP how to map HTTP request to some action in your application. And to do this, IHP uses this thing called a parser. This is from a popular library called Parsec. Essentially, it just takes a string and does some logic, and at the end, it spits out this IO response received, which again is from that Y library from earlier. So our main root application is a collection of other front controllers. So to go in a level deeper, again in Addix, this is the main web application here. See these things called Parse Route and Start Page. Essentially, these are the functions which IHP uses to generate those parsers, so that when a request comes in, it has our list of parsers that map requests to actions. So when a request comes in, it'll run through each one of those and try and see what it works. And the first one that works, that's the code that will actually get run. So you can see here, there's this magical beauty called AutoRoute, which I've been working with lately. So it's been quite a fun time. But essentially, this AutoRoute automatically generates these parsers for you. So this Addix controller is defined here. It's just a normal IHP controller, which is a data type with a bunch of different actions, as they're called in IHP. So the beauty of AutoRoute is it goes through every one of these actions and generates a way for the server to parse a request and tries to map it to one of these actions depending on the action name and its parameters. So an example here, a HTTP request goes to this thing called top performances along with a collection. So if you look back at our type here, we see there's something called top performances action, and it has a collection parameter to it. So AutoRoute will map those two together and then end up calling the implementation of that action here, which is just some logic that renders some view. Don't worry about too much what's happening here. Just want to show you that this code gets executed. So then in this render function, we want to know how this actually returns HTTP. And at the end of the day, that goes back to Y from the very start. So depending on what the content type is, it'll either render HTTP or HTML or maybe JSON. And this might look familiar from the start. As you see here, we're using response builder and status, and we're rendering some HTML. Just like in the first example, we were responding with a status, some headers, and then some HTML string here. So we've finally seen how IHP goes through your entire application, maps it to the right action, and then now finally is using Y to render some HTML, which is sent over HTTP using that Y library. And again, that'll bring us back up here to from controller to Y app where we started, and that will finally return with that data, which then gets sent back to your client and they can see all the data that they need. So in conclusion, our job as web programmers at the end of the day is just to send the right sequence of bytes to our users. Obviously, we don't want to think that way, and we want to be able to write unique applications. And the job of IHP and every other web framework is to help us do that so we can focus on making our app unique. And the fact that you, as an IHP developer, you really don't have to worry about any of that stuff I just talked about to build awesome applications is a great example of the beauty of IHP and part of the magic. Obviously, understanding a bit about how the magic works is helpful, especially when things go wrong. So you can look into it and try to fix it on your own. But this is a great start on getting into that and understanding how these frameworks actually help you at the end of the day. So happy hacking on IHP, and be happy to take any questions.